In our last video, we were multiplying and we were solving problems mentally, and we were allowed to use jottings, but we were partitioning numbers. When we separate them into the different columns, such as thousands, hundreds, tens and ones, we separate them. So we're going to build on this today, and we're learning to multiply. And our success criteria, what I want you to do by the end of the lesson is I can use the grid method to multiply two numbers together. We're working towards multiplying larger numbers and using more formal method. So yesterday we were using partition strategies and we were working mentally. As we start to deal with larger numbers, we might find it easier to use more formal methods. The method that I'm going to show you today is kind of what we call a semi-formal method. It's in between the two. It's in between a jotting and a formal method. You have come across formal methods before because you use them, for example, when you do a column sum, a column addition sum. So let's imagine there were 33 sweets in a bag. So that's 33 sweets in one bag, and we wanted to know how many sweets there were in 5 bags. So most of you might have worked out the calculation would be 5 lots of 33 or 33 lots of 5. Now this is the grid method I'm about to show you here. You still use your partitioning skills and you separate this number here into tens and ones, okay? So you draw a square, okay? And draw a line like so, and a line vertically there, and you put times. So we're just going to actually rewrite the sum in a different way, okay? Because we're timesing by 5, we're going to put the 5 there. This 3 we know stands for 30. This is a 2-digit number, so this is why I'm having 2 columns here. So the 3 stands for 30, okay? And this 3 here stands for the ones, so I'm just going to write it like so. And then, now we've partitioned or separated, we're going to multiply the 10s separately to the ones, okay? So 5 times 30, now we talked about this yesterday, an easy way to do it would be 5 times 3, which have a think is 15, but because 30 is 10 times more bigger than 3, we pop that 0 on, okay? So we've multiplied the 10s. Now we go to the ones and we multiply that separately, okay? 5 times 3, okay? Well, we kind of already worked that out, didn't we? 5 times 3 is 15. So we've multiplied the ones. So we've multiplied the 10s. We've multiplied the ones. We've put our answer here. Have we finished the calculation? Do we know what 5 lots of 33 are? Or 33 times 5? No, we don't. So just like yesterday, we're going to need to add 150 and 15, okay? So it's almost like we've partitioned and we've multiplied separately, but now we're adding the two totals back together for our final answer, okay? Some of you might be able to do this in your head. It's not a problem, okay? Otherwise, you can write out a sum, making sure that the numbers are in the correct columns. So 15, remember the 5 goes in the ones, and that stands for 10, so that goes there. We always start on this side. 0 add 5 is 5. 5 tens add 1 10 would give us 6 tens or 60. This is in the hundreds. 100 add no hundreds is a 1 there. And so the answer that we would get is 165. Okay, so the original question was 33 sweets in a bag. How many in 5 bags altogether? You would have 165 sweets. That is a lot of sweets. Okay, we'll do one more example before you think about your work today. I've set spicy, spicier and spiciest, and the spicy work if you'd prefer to just practice your table facts, that's what you can do today instead of the grid method. But it's good that you're listening to this strategy. So let's try something else, okay? If there were 64 stickers in one tin, okay, how many would there be in 9 tins? Now, some of you might have worked out that we need 9 lots of 64. Now, I've mentioned to you before about how important it is to estimate your calculations so that when you do get an answer that's way off, you actually realise that. So if this is 64 times 9, okay, in order to get a close answer and a quick and easy calculation in your head, you might want to do 64 times 10. Now 64 times 10, you just need to make 64 10 times bigger. It's 640. So we know we're looking for an answer that is not going to be that because we're multiplying by 9, but it's going to be round about in that area, okay? So 64 times 9, okay? Now, it's a 2-digit number by a 1-digit number. So I'm going to draw my chart again. And we're going to set it out in exactly the same way with the times up there, 60 there, 4 there, and we're multiplying by 9, okay? If you want to start in the ones, that's fine. So the sum is 9 times 4. Now, if you remember that clever trick from the 9 times table, in order to do this very quickly, you take away 1 from the 4, which is 3. And then you must think to yourself, what do I add to 3 to make 9? 3 add what makes 9? And the answer is 6, okay? Let's go over here, 9 times 60. So we know that 9 times 6, we can do that first. It makes the calculation easy. 6 take away 1 is 5. What do we add to 5 to make 9? Okay, give you some thinking time. The answer is 4, okay? But we have to be careful. It's 9 times 60, so we've not finished yet. In order to make it 10 times bigger, we add a 0 there. So, bigger numbers now. Draw our addition at the side. Okay, I'm going to have to put the add there because I'm running out of space, okay? Always we start at the column furthest right. So this is our this is our ones, tens, 100. 0 add 6 is 6. 4 add 3 is 7. And 5 add 0 is 5. Okay? So we've got a difference there of 576 and 640. I wonder what the difference actually is. I'm just going to move that across in case you didn't see that earlier. Okay? So that was our estimate, and that was the answer we got. So let's just work out the difference between these two numbers, 576 and 640. I wonder if you will notice anything. So let's see, we could add 4 to get to 580. Okay, we could add 20 to get to the next multiple of 100, which is 600, and we can add 40. Altogether, let's see what we've added to get from 576 to 640 to work out the difference. 40 add 20 is 60. 60 add 4 is 64. Did you notice anything? So we know that 64 times 9 is 576. The reason there's a difference of 64 is because here it is another lot of 64. Now don't worry if you didn't follow that last part. It was just a wee bit of a challenge for some people who might have been able to follow that, okay? Okay, I might just do one more calculation, okay? And I might make it a little bit harder and just show you say if you were multiplying a 3-digit number by a 1-digit number, how you would set it out. Okay. Okay, so if it was 653 times 7, I'm just going to see, yep, you can see that. This time it's a 3-digit number, okay? So basically you would need a bit more space. So I'm drawing a rectangle, okay? We're multiplying by 7. And we would split or partition these into their relevant parts. So we would have 600, 5 is worth 50, the 3 is worth 3. Now this is a bit more challenging, okay? I could go to the ones first. 7 times 3, 21. You remember that trick I showed you for the 7 times table? So we're here now, okay? 7 times 5, because it's the tens, is 35, but we just remember to add on 1 0 to make it 10 times bigger. This is where you've got to think about making sure that you don't make a mistake, because you'll notice that we're multiplying 7 times 600 and it's got 2 zeros. So 7 times 6 is 42. But then to make this 42 100 times bigger, we would add on 2 zeros. And then you would do exactly the same thing again. You would add these 3 products to get the total answer, which you would put up here. And I've just decided I'm going to very, very quickly show you a 2-digit by 2-digit. Now, if you've already decided that you're going to do the spicy times table practice, you can just crack on with that now. If you've already decided that you're going to do the spicier, you could pause the video and crack on with that now. But if you're thinking about spiciest, okay, let's really challenge ourselves. 65 times 32, okay? So you'll notice now that we're not multiplying by a 1-digit number, it's 2 2-digit numbers. How would we set that out? We're still using our partitioning skills. We are still multiplying. So we put our times there, okay? And what we must do now is this. So we've got 32 here, 32, 65 here, 65. And you've got to be really careful. You don't make any careless mistakes, okay? So we'll do, we'll start here, 60 times 2, because we have to do the 60 times the 2. 6 times 2 is 12. Add a 0 to make it 10 times bigger, because there's a 0 on the 60. That's that square done. Here, 60 times 30, wow! So we do 6 times 3, which is 18. And then we add these 2 zeros to make the answer 100 times bigger, okay? Because there's a 0 there and there's a 0 there. It's just about following the rules. 5 times 2, 10. 5 times 30, so 5 times 3 is 15. And of course, we must remember to add that 0 on there. And then you would make your addition sum here. Let's see if I might have to do it this side actually, guys, okay? So we've got 1,800. I'm making sure that all the numbers are going to be lined up nicely. Then 120, because I'm adding all of my 4 products this time. And I've got 4 products because I multiplied a 2-digit number by a 2-digit number. It's really hard, this, okay? I'll squeeze my add sign in there. Let's add the ones first, 0, so that's the ones done. This is the tens, hundreds, and thousands. Tens column, 2 tens, add 5 tens, add 1 10, that makes 8 tens. Hundreds column, 800, 900, 1,000. Now we've made 1,000, so we have to put the 1 here on the doorstep in the 1,000 column and the 0 there, okay? Here. Let's go and add the 1,000 here. Don't forget the 1 on the doorstep. And that is the answer, 2080. Okay? Good luck with your calculations today. That was definitely, maybe not even a spice, just it was more of a hot, hot, hot. Good luck.